And we have looked at decision falling under binary and decision trees, and also we've said logistic falls under binary, right? And we have looked at KNN falls under multi-class classification. And we want to look at one that falls both under multi and binary. That's the Bayesian now. Then when we are done with that, we'll step back out, go into unsupervised, and we'll probably touch on KNN, which falls under clustering. So we spend some time on clustering to see what it's actually doing. It's quite basic, but at least it will take us to a certain point where we can talk about K-means after we talk about the Bayesian. Right. So bear with me as I do a really big jump onto where we are meant to be. And that's where we are. Hopefully you can hear me loud and clear as I start the recording on this. We can
Yes, please. Yes, please. We can hear you loud and clear.
Thank you very much. So basically, we have looked, we've seen that supervised machine learning algorithms basically can help us classify the data. So unsupervised machine learning algorithms can help us cluster. So with supervised machine learning, we are doing classification. Unsupervised, we're doing clustering. In a couple of minutes or from now, we'll be looking at, let me stop the recording, go back. How about that? I'll get rid of this and start the recording anyway. We will be looking at clustering into more details anyway. So for now, we will just sit on there. So let's say we want to look at a slightly different type of algorithm, which is basically mainly based on probabilities. All we are about to look at is just probability. There's just probability. We're looking at a feature, based on the feature, based on what we know about the unknown feature. We're just simply saying that there's a probability that you belong here. That's what we're doing, right? It's just conditional probability. So we say we are looking at how things impact the probability of another thing happening. That's all we sort of thinking about at the moment. Not to confuse ourselves, we don't think too much about it, right? So the most popular among these probabilistic algorithms is the Bayesian ones, and it's actually the Bayesian algorithm is based on a Bayesian theory, right? It is statistics. I'm not going to dig into the statistics. I'm not going to pretend to be the statistician here, but basically it's just probabilities based on some statistics that we do, right? It's called naive, the Bayesian algorithm. It's called naive. It is naive. Let me write that down just in case, and I'll try my very best to make it look really clear as possible. So it's naive-based algorithm, and it is called naive mainly because it's, it thinks that the predictors, earlier we looked at the predictors, right? Things like when we talked about whether someone goes to the beach or not in the previous session, things like the sky condition or whether it's a weekend or weekday, these sort of things predict the output, right? There's a K and then the A and the Y, right? So it looks at certain predictors, but it's considering these predictors as independent of each other. It assumes that the predictors are not correlated in any way. That's why we're saying that Bayesian is naive. Pretty much that's what there is to it. Are we okay with that?
Yes, please.
So if we go back to the example we looked at earlier, which was trying to, I don't know why it's skipping, but let's go back. So the example earlier, which was the dog example, so pretty much trying to find out what type of dog breed that we have. And yes, I would say, I mean, the question regarding the misbreed and other things, if it was with the notion that either you are mixed or not, that's slightly different. Even among the misbreeds, we can have things like toy poodle, or we can have sheep poodle, depending on whether it's a toy poodle and a mix of another thing. So we have different breeds with specific misbreeds with specific features that we can find. So anyway, Still back to that scenario, and we say we want to take some predictors out of these particular dog breeds in order to find out, do some similar classification as we did before. But then we want to use the Bayesian. So we have 3 classes, which is three breeds we're taking out to look at, and we looking at whether, well, it's a terrier or whether it's a hound or whether it's a sports dog. These are the 3 potential classes we are likely to end up with. And we have said that the Bayesian can actually be used for binary, or it can be used for multi as well. So it's sort of fall into the 2 of them, right? So we have the Bayesian falling within binary and then multi. But in this particular case, of course, it's multi-class classification. So we take some predictors. Some of the predictors that we want to look at are hair length, the height, and then the weight. So we notice that someone like me, who is tall, or I consider myself to be tall, can be quite heavy as well, because my weight, which is probably about 90K, is related to my height and other things as well, or whether I'm too skinny or not. But you do have some overlapping features. But with the Bayesian, we say, we're being very naive, we say that the weight is not dependent on the height. Frozen, just 1 second, and we'll be back. You're frozen as well. Can you hear me? Sorry. I lost you for a second. So we say the weight is not dependent on the height, and also definitely the hair is also independent of the others as well. So we're just simply saying that all these predictors, there's no correlation between the predictors, and we want to use them to class each of these, or to class them into each of these. So I would say just a few things to talk about weight, height, and other things, but we come back to the main point. So we take our training data set, look at our training data set, look at, remember we are doing the labeling here, it's still supervised. So we saying that, of course, there's a training data set. If you have a hair of this particular length, there's a chance that you belong to this particular class of dog breed, and we just put it that way. So in the first instance, in order to understand the way that we're doing the classification at this point, for now, let's pretend this particular column doesn't exist yet. The same way, we will forget about this row for now, and we want to concentrate on what is happening within here, within these boundaries for now. Yeah, and we will look at the features as well, or the predictors on the side. So with Bayesian, we say these do not depend on each other. There's no correlation. So let's take each of the predictors. So we take the hair length, and from the hair length, we look at the unknown data to say, okay, looking at the hair length of the unknown data, we've got 40% confidence, like we said, it's probability, which is means 0 to 1, right? Or we just say up to 100%, for example. We say there's 40% chance based on the hair length alone that is a terrier. And there is 10% chance that it's a hound. And also there is about 50% chance that it is a sports dog. Then from that point, we'll look at the height of the dog to say, oh, look, judging from its height, there is about 20% chance that it's a terrier. And say there is about 10% chance that it's a hound. And it's frozen, so give me 1 second. Taking more than a second, and it's back. And there is about 70% chance based on the height alone that it is a sports dog, and it freezes again. Okay, it's back up. Can I do a quick check to see whether you can hear me loud and clear? I'm not sure. Can you hear me all right? Okay, thank you. Right, so then we'll do the same for the weight. In this particular case, we've got 10% chance, we've got 5% chance, and also we've got about 85% chance. But then we should note that this is based on the predictors that we have provided. At the moment, we can say, okay, based on the way our model is working, there's a high chance that it's a sports dog. And you, of course, it's advised you feeding the data into it, and you still have a decision to make. You probably look at the dog and you say that this is most likely a hound more than a sports dog. So you still have a chance to make some decision here. And the way that you actually do this is maybe from your own knowledge, you can tell that as far as dogs are concerned, the strongest predictor or the feature that help you classify or say that this dog definitely belongs to this breed, the strongest feature is the hair, for example. And the other features matter, but not so much. So you say, okay, I'm going to use some weighting, similar to what you do for deep learning. Or you say, I'm going to use some weighting, where I place maybe a higher weighting on the hair, and then the others which do not matter, but not so much, I'll weigh them to each. And of course, it's a decision you are making. So in that sense, we use the weight where we multiply each of them by the weight as well. So each probability by the weight, that equivalent weight that we've assigned to it. And then afterwards, we will find the sum of it. So we use the weighting and we find the sum of each probability. And afterwards, you can tell that, yes, this dog is highly, or there's a stronger chance that it is a sports dog. And of course, there is much, much less chance that it's a hound, and as compared to even it being a terrier. Are we okay up to this point?
Yes.
Okay, thank you. So your main point we'll make with the Bayesian is that it is naive. It's simply thinking that, yes, this is independent of that, that's independent of that. And of course, the predictors are not correlated in any way. So just quick question for the class. Which machine learning algorithm is termed or known to be lazy learning?
Sorry, come again.
Which machine learning algorithm do we term as being lazy?
Okay.
And then naive? Okay, thank you very much. I've got some k-means on this particular slide, but we're not going to use the one. If it helps you to revise better, you can use the one on this slide. I'll still leave it there when I share it with you anyway. But I have another set of slides that I prefer, and I'll use that for the recording to you in a few seconds. So let me stop the recording here so we create another milestone with our